Alright, hello, this is Mr. Clancy, and I'm here to talk about, this video is about the Earth's tilt. Illustrate a couple of key points. I've got this illustration here, and I'd like to run through this with you if I could, because this really illustrates some of the key points beautifully. You can see the Earth in its orbit here, rotating. It rotates on its axis and it revolves around the Sun. And the key parts here are the fact that the Earth is on it is tilted, as a tilted axis. It's on a 23.5 degree angle off its axis. It does not stand up straight, if you will, in its orbit. And let's go through, I'd like to go through some of these key points about the March and the September or the autumnal equinox, and also the June and December solstice, and some of the impact on our environment, if you will. All right, I'm going to start up here with the March equinox. I'm just kind of going over this and add a couple of things in here as the need arises. You can see on the March equinox, the Sun is directly overhead at the equator. All regions of the Earth receive, you can see, about 12 hours a day of sunlight, or daylight, if you will, and 12 hours a day of darkness. The spring, this is the start of the spring in the northern hemisphere, where we are, and the start of the fall in the southern hemisphere, where down in Australia, that area, down under, all right, down under the equator. I'm going to move over here, CCW, counterclockwise, to the June solstice. You can see the northern hemisphere is maximally tilted toward the Sun and experiences the longest day of the year. The summer, you can see, so this is our, I would say, most daylight hours here. The most daylight would be at the June solstice. This would be approximately June 22nd or so. And you can see there that the summer begins. That's officially the start of summer for us in the northern hemisphere. And it's officially the start of winter in the southern hemisphere down under. So I move down here on the what would be called the autumnal equinox. This would be coming up right up to it, actually, in September 21st, 22nd, in that area. The Sun is directly overhead, you can see, at the equator, and all regions of the Earth receive 12 hours of daylight and 12 hours of darkness. And fall begins in the northern hemisphere, spring begins in the southern hemisphere, just kind of the opposite effect of each one. This is our time, just a beautiful time of year coming up into now. Certainly the autumn is a great time here, and I know it's I think it's my favorite season. And then coming down to the last, to number 4 here, the December solstice, winter solstice, where this is the time of least daylight. Right, and when I say over here, when I say most daylight, this would be for the northern hemisphere, and I'm speaking for the north over here as well. All right, so the hemisphere is maximally tilted away from the Sun. Shortest day of the year. It is the longest day of the year. Is just the opposite in the down under, and so this is the key takeaway, is that the Earth's tilt, because you can just kind of follow this diagram for your thought process, but the Earth's tilt is directly responsible for the seasons. So, a couple of impacts on climate that I would like to discuss with you. Right, now, one would be, these are just a couple things this is one key impact. I know I enjoy the beautiful fall colors that are in this time of year, just picturesque. I know I'm from New England, and you see those beautiful colors around here, and New England always had those rich red colors, just gorgeous stuff. Many people take weekend trips just to view the foliage. It's so pretty. How does that foliage occur? Well, the foliage occurs because of this impact of less light. We're getting fewer daylight hours. If you remember down, less photosynthesis. All right. So let's go through this. The beautiful fall colors are actually underneath. They're underneath the green. Underneath the green colors that we typically notice in leaves and stuff. When photosynthesis is taking place, as per this equation, sunlight plus chlorophyll makes the green, plus, or one type of chlorophyll makes the green, I should say, plus carbon dioxide plus water, will produce oxygen plus C6H12O6. This is the sugars or the carbohydrates, which are the key product of photosynthesis. So as this, remember from chemistry, these are reactants, and these are products. So if I reduce one of these reactants, I'm going to reduce the amount of product that takes place. So with less sunlight, the photosynthetic rate is less, which means that there's less green leaves. The pigment of the green the leaves are not photosynthesizing quickly, so there's less green color, and the beautiful colors that are underneath the green get exposed, and this is why we have the beautiful fall colors. So something to think about. The other impact, I'd like you to think about two questions, and we can talk about this in class. We know that the Earth's axis is a 23.5 degrees. So I'm going to ask you a couple of questions here if I could. All right, the first one is, suppose the Earth was not tilted on its axis. All right, suppose it stood straight up, 0-degree tilt, as it went around, as it revolved around the sun. All right, what would our seasons look like? All right, and where would the tropics of Cancer and Capricorn be? All right, I think I forgot to mention that, but basically, right here, if you can see it, this is the Tropic of Cancer, which is 23.5 degrees north latitude. All right, that would be north of the equator, and the Tropic of Capricorn would be at 23.5 degrees south latitude. All right, so that basically coincides. You can see why that would be if kind of look at this because of the tilted axis. So my two questions would be, one is, first was, what would the seasons look like if it wasn't tilted? And also, if it weren't tilted, where would the tropics of Cancer and Capricorn be? The second question I want you to think about is, suppose the Earth was tilted at a 30-degree angle. All right, so instead of 23.5, suppose this was a 30-degree angle on its axis. What would our seasons look like? Where would the tropics of Cancer and Capricorn be? So, I look forward to discussing these with you in class. Thank you very much.